All right, so let's take a minute to look at this calendar. This is today, so hopefully those of you that took your STAR test today did well on your test. We're going to look at the binomial theorem today. Your assignment is in Delta Math. It requires work, once again, that you will submit in Schoology. It's due on the 6th. Tomorrow, your assignment will be your test review. Of course, every day, make sure you're reading what's in Schoology. On Thursday, you will have a test to do on your own, so make sure you are ready for that. I realize, like I've said before, that there's AP testing and things going on all in the mix of this, but you still got to take care of business. Don't give up on one class because you're taking care of stuff in another class. It's all about time management. So, and have a calculator handy for today. I'm using, once again, the Desmos Scientific Calculator. So that's the one you will be seeing from me. Let's look at the binomial theorem, which is still part of or connected to Pascal's triangle. All right, so this says, each element of Pascal's triangle is assigned a row n and an element r. So we have row n, element r. Both rows and elements begin with 0. This is important. Okay, so the nth row, rth element of Pascal's triangle is denoted by this. Here's my n, here's my r. And it's defined as n, r, like this. This is the combination of n things taken r at a time, which looks like this. So here's a review, keyword review, about what that little exclamation point means. This exclamation point means factorial. So factorial is the exclamation point. So for instance, if I have 5 factorial, what that means is 5 times 4 times 3 times 2 times 1. All right, that is a review from, I don't know when you first see it, but I know for sure you see it in geometry when you talk about combinations and permutations. So this is a C here, so this is a combination, not a permutation. We're going to use this format more so than this one, just because it's a little easier to write and a little neater in what we're doing. So if this is n and this is r, this is n factorial over r factorial times n minus r factorial. Look at, again, elements and rows. They both begin with 0. So this is my 0th element, then my 1st, 2nd, 3rd, 4th, 5th in that row right there, which makes that different than the terms in a polynomial that you would do a binomial expansion with, because my terms, this would be 1, 2, 3, 4, 5, 6 terms, but again, I start with 0 when I call them elements. So vocabulary here is very important. You're going to be able to put a lot of this in the calculator. The concepts overall are not complicated, but if you're not using the right pieces at the right time, you're not going to get the correct answer. So let's look at how this works. I want the 6th row, 3rd element. So that means that this is the nth row, rth element, so 6th row, 3rd element. Then I'm going to use this right here. So this is the 6th row, 3rd element. So what this looks like, well, we could write it as a combination of 6 things taken 3 at a time. Then we can write this as 6 factorial over, this is 3, so this is 3 factorial times 6 minus 3 factorial. We're going to do this first one by hand. We're going to do plenty of stuff in the calculator, and it's fine to do it all in the calculator in the end. But it's also important that you understand how this works moving forward, that you understand how to simplify factorials. This one, doing it by hand, is really not that big a deal at all, because I am not going to multiply all this stuff out. What this gives me here is, so I can really say that this is 6 factorial over 3 factorial, 3 factorial. Right, so I'm going to come over here and do my work for this right here. One way to do this, so this 6 factorial, yes, that is 6 times 5 times 4 times 3 times 2 times 1, but it's also 6 times 5 times 4 times 3. Now if I stop here, and 3 times 2 times 1 is 3 factorial, that matches this first one here, 3 factorial, and then I can multiply this one out, 3 times 2 times 1. So here's what happens when I start reducing. I can cancel those out, and then I know here that 3 times 2 is 6, that cancels out with this. This is just a 1. I have 5 times 4. That's equal to 20. That's how it works by hand for factorials. Let's go to the calculator and look at one way to do that. So here my calculator. I want a fraction. And the numerator was 6 factorial. So 6, I'm going to hit function. Here's factorial. I don't have a keyboard up here, so you could probably use the exclamation point in the keyboard. Then 3 function factorial. Then 3 function factorial. And oh look, my answer is 20, just like we got by hand. All right. Let's look at number 3. We don't need to do number 2. So number 3, my 18th row, second element, 18th row, second element. So that's going to give me 18 factorial over 2 factorial times 18 minus 2 factorial, so that'd be 16 factorial. So let's see how we can work this one out by hand. This would give me, this is 18 times 17 times, and now I can stop at 16 factorial because I have 16 factorial down the bottom. And then 2 factorial is just 2 times 1. That'd be times 16 factorial. I can cancel these out. Then I can cancel this 2. Well, I can reduce the 2 with the 18 and make that 9. So I really just end up with 9 times 17, and 9 times 17 is 153. So let's put that one in the calculator as well. Here's my fraction. In my numerator, I wanted 18 factorial. In the denominator, I had 2 factorial times 16 factorial. And oh look, my answer is 153. Okay. Let's do another one. Let's do number 4. So on number 4, I have the 25th row, 14th element. Oh, it's not a fraction, sorry, a fraction bar there. Not a fraction. This is going to look like I accidentally left off fraction bars when I didn't. Although I never leave them off. They disappear. We don't know where they go. So this right here, this is 25 factorial over 14 factorial. And then 25 minus 14 is 11. I could put that in the calculator just like this. But remember up here, see how it also is this? It's the same as a combination of 25 items taken 14 at a time. On some calculators, I don't know which calculator you're using, there will be a combination button on there. Those of you that are in stats, you already know how to do all this with your Inspires. But it's on this calculator as well. Just got to know how to type it in. So when I go to the function here, I was using this, but look, I've got permutation and combination. So for this calculator, once you do that to get the N and the R, so the left-handed number on what we just did was 25. So I'm going to do 25 and then comma, that's this number, and then my R number was 14. And that's my answer right there. We could do that one by hand, but I don't think we want to. It gets kind of big. So this answer here is 4,451,400. So just so you can see that, it is the same thing. I'm going to go back over here, and let's go ahead and do this one with the factorial. So I'd have my fraction. 25 factorial would be in the numerator. In the denominator, I would get 14 factorial times 11, factorial. And you can see that I get the same number. Okay. along those same lines, let's just go ahead and redo this one. This was 18 taken 2 at a time, right? So let's use this NCR here. And we'll do 18, comma, 2. And look, we get the same answer, 153. Okay, so you've got options on how you actually type it in. But understanding it manually, like by hand without a calculator, it's important to understand that, but at the same time, it's okay to use a calculator. It's kind of a, they kind of go hand in hand here. So why don't you, we skipped number 2. We're going to take, we want the 13th row, 5th element. So you do that one, however you want to do that one. Okay, whether you're doing it with the factorials, whether you're doing it by hand, whether you're doing this, just go ahead and take a second and do that. Pause until you're done because I'm about to give you the answer. So no matter how you figure that out, you're going to get 1287. Okay. So these are just the elements in the triangle themselves. They're not the terms in a binomial or anything else. It's just if I was to continue this Pascal's triangle out infinitely, I could find this row, this element, these are the numbers that would be in there, okay? So we are then going to use that to help us find our terms in our binomials, okay? So our binomial expansion, where we were finding like the whole thing yesterday, maybe we just want a specific term from a specific binomial. So but you have to be careful with the numbers, meaning which element, which term, what is r, all that good kind of stuff. So this says the r plus 1th term in the binomial expansion of a plus b to the n is defined as nr, just like what we've been doing, and then a to the n minus r power times b to the r power. Okay, so we're going to, it says find each indicated term. Here's how this works. We've got to make sure that we understand all of our pieces here. So a plus b to the 10th, that means that n is 10. 8th, I want the 8th term. This is the r plus 1th term. That's how you figure that out. So r is not 8, r is actually 7. Okay, so to find r equals the term number minus 1. Okay, here's why. Go back up here and say this again. This is the, let's say 1, 2, 3, this is the 4th term in the binomial expansion, or the coefficient of it anyway, but that 4th term, 3rd element, 5th term, 4th element. So the element number is 1 less than the term number, and the r is your element number. Okay, so this is where we get n from, this is where we get r from. So then we're going to move on forward. So that means what I'm going to have is this combination, and then it's a to the n minus r power, so this is literally a here. So a to the 10 minus 7 power, and then b to the r power. Okay? So however you want to do this 10, 7 here, let's just go back over here. I'm going to clear all this off. I think the easiest way probably here is, but just one of them. So I would have 10, 7. So that's 120. So that means that my coefficient is going to be 120, and then I have a to the 3rd, b to the 7th. So if I was to expand this, a plus b to the 10th, which I don't have to expand the whole thing, that's what I would get. Now I could expand the whole thing. I know, we could do Pascal's triangle, expand the whole thing, but that's my 8th term. That's all I need right there. Okay. So let's try another one. Here's my n, so n is 7. R will be 3. So that means 7, 3 times 3a, this is in parentheses, 3a to the n minus r power, so that's the 4th power, times a negative 2, because remember this is always plus and negative there, so negative 2 to the rth power, which is 3. Okay, so what I would do here, if it were me, is I would take care of my variable first. This is going to be a to the 4th. All the rest of it is a number that's a coefficient. So I'm going to have 3 to the 4th, negative 2 to the 3rd, and then this combination here. So I'm going to make sure I'm just going to take care of it all at once in the calculator. Might as well. So I need the combination again. That combination is 7, 3. I'm going to close my parentheses, times, and then I need 3 to the 4th power, times, and then since this is negative, I'm putting it in parentheses, negative 2, close my parentheses, and that is to the 3rd power. And it does it all in one step. I get negative 22,680. So that means I may not have left myself enough room. I probably didn't. Negative 22,680 is my final, times a to the 4th is my final answer. Okay. So since this can give me specific terms, it could also help me expand this so that if I did want a plus b to the 47th power, that I wouldn't have to actually do my Pascal's triangle out that far. So that's what this part says, which looks all crazy and complicated, but it's just your official mathematical definitions and what they look like. So this says, if n is a natural number, meaning positive integers, then a plus b to the nth power, which we used with Pascal's triangle yesterday, can also be this. This combination of n0, which could also be like this, times a to the n, b to the 0, plus c, the combination of n1, a to the n minus 1. So basically just like we did yesterday with Pascal's stuff, the exponents on a are reducing by 1, on b they're increasing by 1, but instead of getting our coefficients from Pascal's triangle, they're coming from these combinations. So then this is n2, and so forth and so on, until you get down to the very last one, and then it's n, whatever it is. So since you're adding them all up, it's the sum, right? This sigma here is telling us we're taking the sum of those terms. Okay, so we're going to, instead of using Pascal's triangle, we're now going to use the binomial theorem to actually expand each binomial. So here's how this works. N equals 6, right? So n equals 6. I don't need Pascal's triangle anymore. And the way I get my coefficient instead is from the combination. So I start with 6, 0. Then my first term, which is a to the 6th power, 2 to the 0 power, just exactly like yesterday. Plus, then I have 6, 1. Then that's a to the 5th, 2 to the 1st. These exponents still have to add to give me n. Plus, then this is going to be 6, 2, a to the 4th, 2 squared, plus 6, 3, a to the 3rd, 2 to the 3rd, plus 6, 4, a to the 2nd, 2 to the 4th, plus 6, 5, 2 to the 1st. Oh, sorry, I got those mixed. It's not 2 to the 1st. Sorry, a comes first. It's a to the 1st, 2 to the 5th, plus 6, 6, a to the 0, 2 to the 6th. Okay. Now, to do all this, now, am I going to have to do a combination that many times in my calculator? No. Let's think about what this actually means. That's why having a concept of it is good. If I actually wanted to do this, this is going to be 6 factorial over 0 factorial times 6 minus 0, which is 6 factorial, right? Well, another thing to remind you of is that 0 factorial equals 1. So these two cancel out, and I still just have 1 over 1, so this is going to equal 1. Anytime, no matter what this n, all these n zeros, this is always going to equal 1. And then this 6, 1, this would be 6 factorial over 1 factorial times 5 factorial. So that means that would be 6 times 5 factorial over 1 factorial, 5 factorial. These cancel out. 1 factorial is 1, so you just get 6. So the first two will be very easy every single time because this will always just equal n. So as I go through this to clean this up, this is just 1. This is a to the 6th, and this is 1, so I just have a to the 6th. This is 6. This is 2, so that's going to be 12 a to the 5th. Then past that, I'm either going to have to work them out or put them in my calculator. So I'm going to look again that, all right, I'm going to have a to the 4th. This 2 squared, that's 4. So I can go over here and do this, and I'll have 6, 2 times 4. Okay, that gives me 60. So then I'll have 60 a to the 4th. Plus, then I'll have 6, 3, and 2 cubed is 8. So I can just go back right here and just change that to a 3 and change that to an 8, and I'll get 160. This is 160 a cubed. Okay, so let me mark these out. I've done that one, I've done that one, I've done that one. I'll lose my place, so I would suggest maybe you marking these out as well. Then I'll have 6, 4, and 2 to the 4th. So I'm going to go back over here, backspace, make that a 4, and I will make that 2 to the 4th. You don't have to always do them all. So that's 240. So then this will be, that's this one, and I get 240 a squared. Okay, then it's 6, 5, 2 to the 5th. 6, 5, 2 to the 5th. That's 192. Plus 192a. And then here, guess what? We're back to this 6, 6. The last one should always be 1 also if you understand that whole Pascal's triangle. And really this one would also just be 6 if you want to think about that. But the very last, but you got to multiply it by a number anyway. But if I have 6 factorial over, this would be 6 factorial times 6 minus 6, which is 0 factorial. It gives me the same thing as this, right? It's just 1. So I really just need 2 to the 6th power. Or if you're unsure, you can always change that to 6 and change that to 6 as well. And you get 64 plus 64. And we're done. All right. Now, we're going to do one that has more numbers in it. Let's see what that looks like. All right, so n is equal to 5. So to write this out, and this is the work that you have to show, this is going to be 5, 0, and then 3n to the 5th times 4 to the 0. Plus, then this becomes 5, 1, 3n to the 4th times 4 to the 1st. Plus 5, 2, 3n to the 3rd, 4 to the 2nd. Okay. Do the rest. I'm going to do the rest without saying anything, so you can try and write them out as well. Okay, so if you're not done writing those out, you can pause. That's the nice thing about the videos, is you're in control of all that. So let's think about what a couple of these. Remember that this is going to be 1, this is going to be 5 for sure. So then I'm going to have 3 to the 5th and 4 to the 0, so that's just 1. So I really just need 3 to the 5th, and then I'll have n to the 5th. So I'm going to come back to my calculator. I'm going to clear all this off. So I want 3 to the 5th. That gives me 243. So this has 243 times n to the 5th. Plus, then I'll have 5 times 3 to the 4th times 4, and then n to the 4th. So I will have 5 times 3 to the 4th times 4. That gives me 1620 n to the 4th. Okay. Plus, so I'm marking these off. I've done those two, so I don't get all mixed up in my numbers here. Now I'm doing these combinations, which I could do the combination by hand, but I might as well do everything in the calculator. So I'm going to have to do a combination of 5 and 2, 3 to the 3rd, 4 squared. So come back over here. I need my combination, and that's going to be 5, 2, close my parentheses, times 3 to the 3rd, times, I'm going to go ahead and put in 4 squared, even though I know it's 16, because then it'll just make it easier for me to go back and change other numbers. So that gives me 4320. So I'm going to come back over here, and I get 4320, and then I still have to have n cubed. Done with that one. Plus, then I'm going to have 5, 3, 3 squared, 4 cubed. Okay, so 5, 3, and each time when I come back over here, I just decrease this by 1, increase this by 1, oops, and I get 5760. So this is 5760, and then that's going to be n squared. Done with that one. Then I'll have my 5, 4. 5, 4. I can just make that 3 now, and then this is 4 to the 4th. Oh, I knew I was going to mess that up. Okay, 4 to the 4th. Oh, it doesn't like that, so I need a 1 there. I'll just go ahead and put a 1. Easier than retyping things. And I get 3840. So this is plus 3840, and then this was just n to the 1st, so that's just n. Plus, then I know this is going to give me 1 again. This whole thing is 1, so I really just need 4 to the 5th. So my 4 to the 5th power gives me 1024. Okay, and there is this expansion. Alrighty, one more. So we have 5 over x plus y to the 4th power. That one definitely doesn't look like it would be fun to actually multiply out. Our n here is 4. So we go through here, and I'm going to have 4, 0. First term, 5 over x to the 4th power times y to the 0 power. Plus, then we get 4, 1 times 5 over x to the 3rd power y to the 1st power. Plus 4, 2, 5 over x squared times y squared. Plus 4, 3, 5 over x to the 1st, y cubed, plus 4, 4 times 5 over x to the 0 power times y to the 4th. Okay? So now, we know that this equals 1, and we know that this equals 4. That's just going to make things a little simpler for us here. So 5 to the 4th power. 5 times 5 is 25, times 5 is 125, times 5 is 625. Or, if you think about it this way, look how this works. 5 times 5 times 5 times 5. This is 25, and this is 25, and we should know that 25 times 25 is 625. Times 1, so my number is 625. That y is to the 0 power, so I don't have any y's, over x to the 4th. Plus 5 cubed, 5 times 5 is 25, times 5 is 125. So 125 times 4, if you have $1.25 and you multiply that by 4, you have $5. So this is 500. You do have y to the 1st, and then x is still in the denominator over x cubed. So then, I have a combination of 42 times 25. So now I can go to my calculator. I'll do my combination, so I don't have to think too hard. 42 times that 5 squared, which is just 25, and I get 150. So my number is now 150. Let's see, I've done this one and this one. 150, and I have a y squared, and I still have x squared in the denominator. That one's done. Then I have a combination of 4 and 3 times 5. So I can make that 5, and I can make this 3. And oh look, that gives me 20, because 4 times 5 is 20, and this right here would have to be 4. So anyway, I get 20. This is y cubed, and I still have an x in the denominator. So then I know that this 4, that's got to be 1 as well. This whole thing to the 0 power is 1, so I just have plus y to the 4th at the end, and I'm done. There you go. Your assignment is in Delta Math. Make sure you come back tomorrow and read your stuff in Schoology so that you know what to do about the test review and then your test on Thursday. And good luck on whatever other tests you are taking this week.